Hello there, young ones, and welcome again to yet another teaching module in economics. We are studying currently the topic of statistics. In it, we have learned so far the topic of classification of data. We went on to learn about organization of data, and now we're moving on to the next topic, which is presentation of data. So are you ready to learn something new? Stay with me then. In this teaching lecture, we will study about the tabular representation of data. We will learn about the parts of a good table. Some examples of various tabular representations will be taken. We will also begin with geometric presentation of data, and in this video we will only deal with simple bar diagrams. I want you to take a look at the table that is represented here. Well, this table tells you about the contribution of various sectors of the Indian economy in the GDP, that is the gross domestic product, from the years 1983 up to the year 2003. So you have the data given here, what in percentage. There is a footnote here which says 2003 refers to 2003-2004, that financial year. The data are preliminary. Gross domestic savings figures are taken directly from India's Central Statistical Organization. So you even are given the source of the data. And of course, it would have been better if the title was represented more clearly in this table. So that brings us to learning about what are the essentials of a good table. In a good table, the title of the table must be properly indicated or given, which is kind of missing in the table that is shown here. The size of the table should be in accordance with the size of the page. So if we are presenting data on a particular page of a report or a book, it should be proportionate to the rest of the written matter that is in the page. The table should be capable of enabling us to compare data. So we can easily compare, for example, in the table here, we can compare the proportion of the various sectors in terms of percentage in the GDP with the year 1983 and the year 2002. So we are able to do some studies, some comparison in this table here. The source note, the head note and footnote must be properly given. So that brings us, let us define now what is tabulation of data. As you can see, when data is presented in rows, horizontally, and columns, that is vertically, it is known as tabulation. There will come a point in your academic career and perhaps even at your workplace wherein you will have to present a report or a project or an assignment. And there, after you collect your data, you organize it, you classify it, you will have to come to a point where you may have to present your data in the form of a table. And so you need to look at what are the essentials of a good table. Well, the first element of a good table is it has to be numbered. So the first part of the table is the table number. When there are many tables, then the tables should be numbered in a logical sequence. For example, different tables will have different numbers. Example, table number 3.1 represents the first table in the third chapter of a report. Table number 4.5 will indicate the fifth table in the fourth chapter of a book. The second part of a table is, of course, its title. It should be clearly stated. A title is a brief explanation of the contents of the table, what the table contains, in other words, and explains that information which is related to the data. A good title is short and clear but complete in all respects. So it has to be brief as well as it should give you a picture of what the whole table is all about. The next part of a good table is called the caption or column heading. Now what is a column heading? A word or a phrase which explains the contents of a column of a table is called a caption. There may be subheads when information contained in the column is to be divided in more than one category or class. Next we have the stubs or the row heading. Now stubs or titles of the rows of a table. These titles indicate information contained in the rows of the table. The complete left column is called the stub column. Next we have the body of the table. It means the sum total of items in the table. It shows values of different items in the table. Each item in the body of the table is called a cell. The data is arranged in this part of the table according to the description of the column headings, that is the captions, and the row headings, that is the stubs. Of course, we need to mention the units of measurements which are used. For example, if we're talking about profit, income, loss, expenditure, we will be measuring in terms of rupees or whichever currency we're talking about. The unit of measurement of the figures in the table should always be stated along with the table. If different units are there for rows and columns, this must be stated along with the stub entry or the caption entry. Of course, we have the source note. We need to know where our data has been obtained from. Where is it sourced from? When tables are based on secondary data, that is published sources, the source of the data is to be given in the source note. Example, the name of the publication, the book, the name of the book, the page number, and so on. If the data is obtained from any organization like the NSSO or the CSO or the IMF or the RBI, that can be mentioned in the source note as well. Here I have displayed for you a sample of a typical example of a good table. Well, you will see that it contains all the parts that we just spoke about earlier. It has the table number, which is table 4.5. It indicates that this particular table is the 5th table in the 4th chapter of a book. The title of the table is Population of India according to workers and non-workers by gender and location. So as brief as we can be, we should have the table stated in this way, which indicates to us not only what the table is speaking about broadly, but as well as the sub headings that we are looking at. So here we have the column headings. Now the column headings are also known as captions. So we have column headings location, gender, workers, which again is divided into subheadings here, main, marginal, and total. We have another caption here, non-worker and total. Note that these are headings of the columns that they represent. So we have the units or the units of measurements that are specified. The data is in crores. Here we have the body of the table. Now when we're looking at the body of the table, each of these entries or each of these squares wherein data is represented or numerical data is shown is called a cell. So the body of the table comprises of cells. Here we have the row headings. Now rows are horizontal, as you can see, and we have row headings which are all urban, rural. Again, the row headings are subdivided into subheadings: male, female, total, male, female, total, urban, male, female, total, all. We have the source note. So we know where our data is sourced from. It is obtained from the Census of India 2001. Here we also have a footnote. Now footnote can explain any extra details that we need to know about the numerical data that is given in the various cells in the body of the table. So here it says figures are rounded to the nearest crore. So this gives us an idea of what an ideal table should be like. Here I've put up for you the format of an ideal table which contains all its parts. So anytime you come to a point where you have been given a project or an assignment, you've collected data, you've classified, you've organized, now you have come to the point where you need to present your data, here is a format that is not filled up. So you can use this format to adapt for any kind of data. You have the table number, the title, head note if any. You could mention the units of measurement here. You have the stub headings or the row headings, Stub entries will come in the first column, that is the extreme left column. Then you have the column headings, which is the caption, and then you have the total of the rows indicated to the extreme right. You also have subheadings in case you classify or categorize your data further. Then you have the body of the table wherein all your numerical data goes. As I told you earlier, every part of the body is called a cell. Then you have the total of the columns shown right down beneath the table. Beneath the table you have the source note where your data has been obtained, and any extra information about the numerical data can be put in the footnote. Here I've indicated another sample for you to show you how a table is represented in real terms in a report or a book. Now this table, as you can see, has all its parts. You have the table number, the title of the table. It tells us the details of what the table is all about, studying the youth activities in the Philippines and the US. The Philippines in the year 1996 and the data of the US youth in 1993. It tells us various aspects in the stub entries or the row headings. We see we are studying in the table the percentage of youth listening to radio almost daily, or watching TV almost daily, reading books, magazines, newspapers almost daily, get together with friends almost weekly, watch movies at least once or twice a month, exercise almost daily. So numerical data is in terms of percentages. So you have the column header or the captions, you have the stubs or the row headings, you have the body of the table where you see all the numerical data and you see the various cells in the table. You have the source note. So it tells you that the table is obtained from a book called Monitoring the Future, a study of the lifestyle and values of the youth. This data was presented in the year or studied way back, the base year was 1993 and the population studied was 2,700. So it gives you an idea of how people present tables practically. You could use any magazine, a periodical or a newspaper would give you several examples of tabular representation of data. Now from the examination point of view, how will we be tested on presentation of data in the form of a table? You could be given a description like this, which is actually an interpretation of a table. And after reading the description or the interpretation, you have to draw a table or present the data in the form of a table. So this is how it could be asked. Present the following information in a suitable table for the year 2015-16. There are a total of 400 students in St. Joseph's Higher Secondary, out of which 320 are boys and the remaining are girls. So definitely this is talking about gender-wise distribution of students in a particular higher secondary. Out of the boys, 200 are from the arts stream and 50 are from the commerce stream, and so the remaining will be from the science stream. The total science students are 90 and art students are 250. The table is the fourth table in the fifth chapter of a book. The information is obtained from the Directorate of Education. So how do we begin with the table? First things first, the table number. We just read that the table is the fourth table in the fifth chapter of a book. So the table number is 5.4. Here we have a brief description of what the table is all about. It is about the gender-wise distribution of students of St. Joseph's Higher Secondary stream-wise. The head note is they are actual figures of the academic year 2015-16. Here we have the table with its row headings, its column headings, the body of the table, the cells, numerical data shown. Then we have the source of the data. The last statement told us where the data has been obtained from, the Directorate of Education. Now let us go to understand how did we fill up this table. We know that there is a total of 400 students. So we put the various streams up here and the column headings and the boys and girls in the row headings or the stubs. So you have the total of all students, be it stream-wise or gender-wise, down here. So there are 400 students. The first entry tells us and out of which 320 are boys. So out of this 400, 320 are boys. So how did we get how many girls are there? 400 minus 320. That gives us 80. So there we got the total number of girls. And we have the total number of boys, which was given to us. So the first two statements are taken care of. Now out of the boys, 200 are from the arts stream and 50 are from the commerce. So you have 250 students here. You take that number 250, minus it from 320, and you will get the number of science students, because the statement here was remaining from the science stream. So you just add up the students from the arts and commerce, and you minus it from the total number of boys, you get the total number of students in the science stream. The total science students are 90. So if the total science students are 90, then 90 minus 70 will give you the number of girls who are in the science stream. The total art students are 250, and you know that the boys were 200. So 250 minus 200 will give you the number of girls in the arts stream. That's how we filled up the numerical data in the body of the table. And you could be probably given a description like this, wherein you will have to come up with a table which has all its parts, of course, or you could be given a table and you could interpret it or explain it. Now moving on to the next part, which is the diagrammatic representation of data. Now, diagrammatic representation of data provides a quick understanding of the actual situation to be explained by the data. It makes the data interesting and simple. You know, even in newspapers and magazines, you see pie charts, pie diagrams, histograms, frequency polygons, you see various bar diagrams, multiple bar diagrams, component bar diagrams, and so on. And it makes data interpretation so very easy and so very interesting. Now, there are many diagrams in common use. Some of them are geometric diagrams, frequency diagrams, and arithmetic line graphs. What we will begin today with is geometric diagrams. Here's beginning with geometric diagrams. Now, bar diagrams are most commonly used. Most often they are one-dimensional, but now with the amount of infographics that we can have so many different types of bar diagrams that can be 3D and multi-dimensional. And a bar is a rectangle whose length indicates the quantity of the variable or the frequency which the bar is representing. The width of the bar is not important in a simple bar diagram. Bar diagrams are of three types: simple, multiple, and component. Now, a diagram that would wherein the width of the bar would be important would be a histogram. That we'll be dealing with later on when we are learning about frequency diagrams. As you can see here, on the y-axis, the difference between sale proceeds and costs is represented, and on the x-axis, we have represented the years of study. So the length of the bar would indicate the value of the variable. And so you see how interesting the data looks. Not only that, with one glance, we can make out a whole lot of things about what we are studying here. It tells us we can compare the data of 1 year with another year, or even further down in recent years. And it makes comparison easy, it makes interpretation easy. So let's see how we're going to use them. Here we have a simple bar diagram. We have a table. This table is represented in the form of a diagram. So this here is a tabular representation of data, and this here is the diagrammatic representation of data. So in the table we see various countries and their birth rates given. We're going to represent this in the form of a diagram. So birth rates, or the value that is changing here in this table, is represented on the y-axis, and the various countries are represented on the x-axis. So it clearly tells us, it shows us that the birth rate here is 35. In the case of Germany, it's 15. In the case of UK, it's 20. In the case of China, it's 40. And in the case of Pakistan, it's 15. So it's so easy to understand or interpret data in the form of a diagram. Here I have for you another example of a simple bar diagram. In this table, the profit in rupees lakhs of a particular firm in its various quarters has been represented. So the first quarter profit is 15 lakhs, second quarter, that is the second 3 months of the year, is 30 lakhs, the third quarter the profit is 25 lakhs, and the fourth quarter the profit is 20 lakhs. This very tabular representation can be translated into a diagrammatic representation like this. Now students, when you draw your diagram, the first thing you need to do is label your x and y axis. We represent the quarters on the x-axis. So you have quarter 1, quarter 2, quarter 3, quarter 4. And then you have the profit in lakhs, which is represented along the y-axis. So you got to label that. First things first. If you don't do this, the data within the diagram that you're trying to indicate or represent or show is meaningless. So first thing you need to do is label your diagram. Then you can represent the various values. You can say 1 centimeter equals to 5 units. You can mention it here at the top right corner, and then you can plot your various frequencies or the values of various quarters, the profits in various quarters. So here we have quarter 1, the profit is 15 lakhs as shown in the table. Quarter 2, the profit is 30 lakhs, which is shown in the table. Quarter 3, the profit is 25 lakhs, which is shown here. And quarter 4, the profit is 20 lakhs. So just visually, it gives you a good feel of the data. You are able to interpret or analyze or even compare your data. So you can clearly see that in the second quarter, the profit was the highest. So it's so easy to interpret a diagram, isn't it? And that is why we realize that we come to the step of presentation only after a whole lot of process that we've gone through. We collected the data from primary and secondary sources. Then we classify the data, we organize it, and then we come to the point where we need to present it and make the data so interesting that anyone who's reading your report, your project, or your book would be able to understand easily through a visual representation like this. You remember the table you looked at earlier that we drew on the basis of an explanation or a paragraph? Well, I put that in the form of a diagram, a simple bar diagram. But in this case, you have multiple bars. So you have 2 bars. 1 bar representing the number of boys in various streams and 1 bar representing the number of girls in various streams. In the video that will come next, in the following lectures, we will deal with multiple bar diagrams and component bar diagrams in detail. So in this lesson, we learned about tabular representation. Under geometric diagrams, we learned about the simple bar diagram. We have come to the end of this teaching module, but I will leave you with a quote, and that quote is by Peter Sondergaard of Gartner Research. So this person is involved with research, and he says, information is the oil of the 21st century, and analytics is the combustion engine. So all the data that we are working with, we are collecting, we are classifying, we are organizing and presenting is all for the purpose of analyzing, so that we come up with some conclusions, so that we come up with some ideas what can be done in the future, either in the field of banking, business, economics, economies, in research, by research scholars. All this data could be needed. And of course, we're playing with the data all the while. You see it up on the screens on news channels. You see it up on the newspapers. It's everywhere. And we can't do without data. And we know, we've learned at length the importance of statistics. So I don't have to talk about that now. Thank you for giving me a listening ear, children.